Hello friends, welcome to the online lecture series of Basics of Computer Network. Myself, Assistant Professor Mr. V.R. Vadekar from the Department of Electronics and Telecommunication from Matoshi College of Engineering and Research Center, Nasik. We are discussing unit number 2, that is error detection, correction and data link control. So let's start with our today's lecture. Before that, students, we would have a quick revision that what we have studied in last lecture. If you remember, in previous lecture, we have discussed about stop and wait ARQ of noisy channel protocol. In stop and wait ARQ, we came to know that at a time, sender it is going to send only one frame, that is the outstanding frame, and waiting to the acknowledgement. After acknowledgement only, it is going to send the next frame. So from the numerical point of view, we have seen the how the efficiency of stop and wait ARQ is here. So if the system capacity, suppose it is a 20,000 bits to send, and whereas stop and wait ARQ it is going to send only 1000 bits, then there is the link utilization percentage is only of 5%. So we have seen the improvement that instead of a one frame which consists of 1000 bits, if we are going to send the 15 frames and then waiting for the acknowledgement, then there is a huge improvement in its efficiency. It goes up to 75%. So in order to fix this problem, in order to overcome these disadvantages, let's start with our today's protocol, that is go back and ARQ. Now guys, in go back and ARQ, the sequence numbers are modulo 2 raised to m, where m is the size of the sequence number field in bits. So basically guys, go back and ARQ protocol is used to improve the efficiency so that multiple frames should be in transition while waiting for acknowledgement, or we can say that let more than one frame to be outstanding. Now in go back and ARQ, we can send up to W frames before worrying about any acknowledgement, and also we keep a copy of these frames until the acknowledgements arrive. Now the send window, it is an abstract concept that we are going to use in go back and ARQ, which is nothing but your imaginary box of the size 2 raised to m minus 1. It means the window size was 2 raised to m minus 1. And we are going to use the three variables, SF, SN and S size. So SF, it is going to tell you the first frame of the window, whereas SN, the next frame that to be sent of the window. S size, it tells you what size of the window. So suppose you would get the clear concept of modulo 2 raised to m, how we are going to give the sequence number. So suppose let m equal to 3. Let m equal to 3. Therefore, the sequence number, or we can say the imaginary box of the size, it would be what? 2 raised to 3 minus 1. It means it is 8 minus 1, that is equal to 7. So what should be the sequence number? Sequence number, then it would be 0, 1, 2, 3, 4, 5 up to 6. Since it is modulo 2 raised to m, then again we are going to repeat this same sequence, 0, 1 and so on. Now guys, this is the send window for this your go back and ARQ protocol. Now you can observe it that this is the window. This is the window. It is a starting and it is the end of the window. Now, can anybody tell what is this size of the window or what m is equal to over here? Now you can observe it. We imagine that all the frames are stored in a buffer, and the outstanding frames, these are the enclosed in this window, which is shown in this gray region. Now the frames to the left of this window, these are the frames that already being acknowledged, and so we can purge it, we can discard this. Whereas those to the right of this window, it can't send these frames until the window, it slides over them. And since the size of the window, it is what? 2 raised to m minus 1. So I ask you the question, can anybody tell what is the value of m? So you can see it, guys, 0 to 14. It means 15. It is a window size. So 15 is equal to, from this formula, we can this 2 raised to m minus 1. Now I think you get the conclusion, or you got the idea what should be the value of m. Definitely m over here, it should be equal to what? It should be equal to 4. That is 2 raised to 4. It means 16 minus 1. That is 15. So over here, s size, this variable, is equal to what? Is equal to 15. Now, and this size of the window, it is fixed. Although we have a variable size window in other protocols such as TCP, this window, it slides to include new unsent frames when the correct acknowledgement are received, that we see it later on. And this window, it is a sliding window. Frames 0 to 6, you can observe it shown in this orange color. The frames 0 through 6 have been sent in part A, right? But not acknowledged. Whereas frames from 7 to 14, these are the frames that can't be sent because it is not received from the upper layer as your network layer. So you can see the variable SF, it is going to tell you the first frame of this window, whereas SN, it is going to indicate what? The next frame, that is, we are going to send the next frame number 7, that to be sent to the receiver. So this is the send window before sliding. Now see what happens when the send window, it can slide one or more slots when a valid acknowledgement arrives. So this is the send window after sliding. Earlier it was the position of this window, it was over here. So when the valid acknowledgement it receives, you can see that this window, it slides for this 3 slots. Now this SF changed to 3 because this is the first frame of this window, because we got the acknowledgement for frame number 0, 1 and 2. So that's why 3 frames have been acknowledged. Now this frame window slides over 3 slots and SF3, whereas SN, it is 7 because there is yet to receive this acknowledgement for frames 3 to 6. Now, talking about a receive window. The receive window, again, it is an abstract concept which is defining an imaginary box. And remember, the size of the receive window is 1 with one single variable, that is Rn. And this window slides when a correct frame has arrived, and sliding occurs only one slot at a time, not as like your send window. So you can observe it on the screen that the receiver, it is always looking for a particular frame. Over here, Rn is equal to 3. It means receiver, it is going to expect frame number 3. Again, this window, it is of only, the size of the window is only 1. Now the left side of this window, these are the frames that already, received and acknowledged, whereas to the right of this window, the frames that can't be received until this window it slides over here. And when suppose we got the acknowledgement from frame number 3, then this window, it shift to the next slot. It would be then Rn equal to 4. So as soon as we would get this frame number 4, this receive window would shift to frame number 5, and so on. Now guys, question is, why window size it should be less than 2 raised to m? Because we have just seen the size of the window, it should be what? 2 raised to m minus 1. Why is it so? Why not it is 2 raised to m? So let's clear your doubt. So first we would, discuss the correct version, that why we have selected the window size less than 2 raised to m. So over here, m is equal to 2. Since m is equal to 2, then what should be the size of the window? The size of window, it would be what? 2 raised to 2 minus 1. That is 4 minus 1. It means the size of the window over here, it is 3. So we have taken the example of window size 3. S size is equal to 3. Now, if the size of this window is 3, see over here, SF is equal to 0, SN equal to 1. Frame 0, it has been sent to the receiver and it has sent the acknowledgement, but unfortunately this acknowledgement, it has been lost. So we are assuming that, from the receiver to sender direction, the link is not reliable, whereas from sender to receiver link is reliable. All the frames have been reached to the receiver, but you can observe it on the figure. From the figure, all the 3 acknowledgements are lost. So guys, frame 0, it has been sent. So Rn over equal to 0. Now, as soon as this frame 0, it has been received, and Rn, it shift for the 1 slot, then over here Rn equal to 1. So since the timer, it has been started and the timeout period, it doesn't happen. So the sender, it is going to send now frame number 1. As soon as this frame 1, it is received, then Rn is shift to 2 because it got the frame number 1. Again, for acknowledgement, it is going to send the acknowledgement that I receive frame number 1, but unfortunately this acknowledgement, it also get lost. Similarly, since the timeout period, it has not happened, so sender, it is going to send the next frame, that is Sn equal to 2. It means frame 2, it has been sent. So Rn equal to 2, yes, it matches. Then receiver, it is going to accept this frame. And after that, it is going to send the acknowledgement. But the problem over here is that the timer, it expires, but no acknowledgement, it is being received by the sender. So that's why the sender, it is going to resend all these frames starting from 0, 1 and 2. But over here, Rn is equal to 3. It means receiver, it is going to expect frame number 3. Why is it so? Because receiver has received all these 3 frames, 0, 1 and 2. So it is expecting frame number 3. But unfortunately, it is going to send the frame 0. It is going to resend it. So it gets duplicated over here, because over here also we receive the frame number 0, and sender, it is going to still sending the frame 0. Then receiver, it can easily correctly, it could discard this frame number 0. So there is no copy of your duplicate frames. Now guys, suppose we are going to keep the size of the window is 4. that is only 2 raised to m, then what would happen? Now we would see it. Now see carefully, guys. Now we have assumed the size of the window over here is equal to 2 raised to m, that is 4. Okay. So again, we are assuming that the forward link from sender to receiver, it is a reliable link. All the frames have been reached to the receiver, whereas the reverse from receiver to sender, the link, the channel is not reliable. So all the acknowledgements are get lost. So now you would again observe it Rn equal to 0. So frame 0 it has been sent. Again this acknowledgement it is get lost. Since the timer it has been started from frame 0, so Rn increments by one slot. It shifts to the slot number 1. It means it expects frame number 1. Also the timer it doesn't expire. So sender it is going to send frame 1. For this frame 1 it is going to send the acknowledgement, but still acknowledgement it is being lost. But receiver receive this frame number 1. So it is shift to the slot number 2. So frame 2 it has been sent. Again the acknowledgement from the receiver side it is being lost. Similarly, frame 3 it has been sent. An acknowledgement it has been sent. But if you will observe, all the acknowledgements are lost. So sender get confused whether my frames are destroyed or acknowledgements are destroyed. So it thinks that since frames have not reached to the receiver, so again it is going to send the frame number 0, this frame number. But since as it is going to follow the sequence number modulo 2 raised to m, so after 3 the sequence number again it is going to repeat 0, 1, 2 and 3 so on. So you will observe it since Rn over equal to 0, right? But it is going to send the frame 0 of this previous window. So sender it is going to send this duplicate frame number 0. But this time the window of this receiver unit is expects frame 0. So it accepts that, it accepts frame 0 not as a duplicate but as the first frame in this next cycle. This is a next cycle. This is a previous cycle, right? Unfortunately, guys, this receiver it is going to accept this frame 0 thinking that this is a frame 0 of the next cycle, but it is that duplicate frame that receiver already having this. So that's why the window size it should not be equal to 2 raised to m. It should be, I mean to say, it must be less than 2 raised to m. So hope so, guys, you got the answer. And this is the example that we have discussed, that why the window size it should be less than 2 raised to m and it must not be equal to 2 raised to m. Otherwise it would take this, accept the data as a new one, but it was a duplicate data, and over here it would correctly discard this frame. So in Go Back N ARQ, the size of the send window must be less than 2 raised to m, and the size of the receiver window is always 1. Again, we are going to take one example which shows that the forward channel is reliable but the reverse is not. Just please carefully see this example. The figure it would come after this slides. No data frames are lost, but some acknowledgements are delayed and one is lost. This example also shows that how cumulative acknowledgement it can help if acknowledgements are delayed or lost. And after initialization, guys, remember there would be 7 sender events and request events are triggered by this data from the network layer. And there is no timeout event here because all the outstanding frames are acknowledged before the timer expires. And note that although this acknowledgement 2 is lost, but acknowledgement 3, it serves as both acknowledgement 2 and acknowledgement 3. So let see the figure on the screen. So see it over here. Frame 0, it has been sent. The timer, it has been started. Sender A, it is going to send frame number 0 because over here SF equal to 0 and SN equal to 0. So frame and RN, it is also going to expect frame number 0. It is the initialization. Frame 0, it has been sent. And acknowledgement 1, it has been given by the receiver to the sender. So as acknowledgement 1, it arrives, which tells that I expect now, receiver, it is going to tell the sender, now I expect frame number 1, I receive frame 0. So this is the meaning of acknowledgement 1. Okay. Now, what would happen now? Since Sn equal to 1 now, see the window, it has been shifted by this one slot. So frame 1, it has been sent by the sender to the receiver. So as soon as the receiver, it is going to receive this frame 1, RN shift to this frame 2, but receiver, it is going to send the acknowledgement 2. But unfortunately, this acknowledgement 2, it is being lost. But the timer, it doesn't expire still. So the sender, it is going to send the frame 2. Receiver, it is going to accept this frame 2 because it was expecting frame 2. Although receiver doesn't know that acknowledgement 2, it has been lost. Now frame 2, it has been received. So RN, again, it is shift to one slot. Now RN, it is going to expect frame number 3. So now acknowledgement 3, it has been sent. And you can see it, observe here. It takes time to reach over here. But during that time, frame 3, it has been sent because this event, it has been triggered. So frame 3, it has been sent to the receiver. Now Rn is equal to 3. So frame 3, it is accepted over here. Now this window, it is just shift to the next slot, that is now Rn equal to 4. Hence it is going to send the ACK 4 over here. Now as soon as you can see it, as soon as the acknowledgement 3, it is received over here, then sender, it comes to know over here, guys, although acknowledgement 2, it is lost, now acknowledgement 3, it is used as a cumulative acknowledgement. It means it is going to serve both acknowledgement 2 as well as acknowledgement 3 itself. And after that ACK4, it has been received. It means sender comes to know that all the frames have been received by the receiver. Now receiver, it is going to expect frame number 4. So as soon as this timer, it is going to stop, and when it is going to send this new frame number 4, again this timer, it get started. So hope so, guys, you understood this example. Now in next example, guys, we are showing that what happens when a frame is lost. So suppose frame 0, 1, 2, 3 are sent. However, frame 1 is lost and the receiver receives frame 2 and 3, but they are discarded because they are received out of order. This is another scenario, guys. The sender receives no acknowledgement about frames 1, 2 or 3. So its timer finally expires, and then senders it is going to send all the outstanding frames, frame 1, 2 and 3, because it doesn't know what is wrong. So resending of frames 1, 2, 3, it is a response to one single event. So now when the sender is responding to this event, it can't accept the triggering of other events. This means that when acknowledgement 2 arrives, the sender is still busy with sending frame 3. And this physical layer, it must wait until this event is completed, and there the data link layer goes back to its sleeping rate. And remember the vertical line to indicate the delay. Now let's see this flow diagram. So as we have told that, you can observe it. Frame 0, it has been sent. Earlier Rn equal to 0. So receiver, it is going to keep this frame. It is going to accept the frame. So by receiving this frame 0, Rn increments by 1 slot. So it sends ACK 1. So as soon as this ACK 1, it received this window, it slides by 1 slot because it received the acknowledgement 1, which means frame 0 it has been received, and receiver it is going to expect frame number 1. But you can observe it that when the frame 1 it has been sent, it get lost. It is not received by the receiver. But since the timer it is not expires, so the sender it is going to send the frame 2. But you can observe it over here. Rn it is not shifted to 2. Why? Because it has not received frame 1. So frame 2 is discarded. Similarly, timer it is not expired. So once this event it has been triggered, sender it is going to send the next frame number 3, but still Rn value is equal to 1. Since receiver expect frame 1 and sender it is going to send frame number 3, so again it is going to discard this frame 0. But during this timeout period, sender thinks that no acknowledgement it has been received for frame 1, 2 and 3. It means something is wrong. It doesn't get the idea. So what it is going to assume, that my frames are lost, so I am going to resend the frame. So that's why it is going to resend this frame 1 of the previous cycle. So as it, the frame 1 it is received, then it is Rn it is going to shift by 1 slot, and now it is going to expect frame number 2. So as soon as it receives frame 2, it going to send the acknowledgement 2. This acknowledgement 2 it is received at this instant, but sender it is busy in sending this frame because this event is already being triggered by this time period. So frame 2 it has been resent, frame 3 it has been resent, and accordingly the receiver window Rn it is going to shift. So now you can observe this vertical line over here. It is going to tell you this, that sender it is busy in sending the frame, although it has received the acknowledgement. So this is the delay in accessing the acknowledgement. So when it is going to read this acknowledgement, then and only then this window it is going to shift. Otherwise, see that position of the window was constant, because this is a delay due to which the receiver hasn't shifted its window. Although it has received this acknowledgement number 2, but it was busy in sending frame number 3. And similarly, this delay it happens for acknowledgement 3 and acknowledgement 4 also. So this is also the scenario that could happen, and depending on this acknowledgement it is received, the sender window it is going to shift its window according to its appropriate slots. So hope so window, we have covered all the scenarios that could be possible in your go back and ARQ. Now you understood why we are going to call it as a go back and ARQ, because it is going to resend the frame. It goes back and again it is going to resend the frame, because receiver it is not going to accept those frames until it receives in a proper sequence, proper order. So we have studied about go back and ARQ. By this go back and ARQ protocol, we are going to improve the efficiency. Instead of waiting for a single frame to be acknowledgement, depending on the number of frames that being included or covered in that window, we are going to send those frames and then we are going to waiting for the acknowledgement. Then we have seen the various scenarios, how what would happen when the frames are lost, what would happen when the acknowledgements are lost, what happens when the timeout period it happens. So all these things we have studied in go back and ARQ protocol. Now this is the assignment that you need to solve it. So please note down this assignment. In next module, we are going to see the topic that is a selective repeat ARQ. It is the last protocol of noisy channel. This is my email address. And here it's all about today's lecture. Thank you very much.